Welcome everyone. Today on the live interactive session number 4, we are going to discuss some sample problems which are based on assignment number 4 for the course Natural Gas Engineering. I am the TA of the course and my name is Ananya Mandal. So let's start with the first question. So the answer the questions 1 to 4 from the data given below. So the data says that a zero point 0.6 specific gravity gas flows from a 2-inch pipe through a 1-inch orifice type tube. The upstream pressure and temperature are 800 psi and 75 Fahrenheit respectively. The downstream pressure is 200 psi measured 2 feet from the orifice. The gas specific heat ratio is 1.3. The choke flow coefficient is 0.62. So these are the information that you will have to use for the next 4 questions. So the first question is the type of flow in the gas well is. Options are A sonic, option B subsonic, option C supersonic or option D none of the above. So how to solve this question? To solve this question we have to find out first what is the P out by P upstream. For that we need the value of K. So K value is already given to us, which is the gas specific heat ratio, that is 1.3. So as K value is known to us, from using this K value in this equation, we can find out the ratio of P outwards by P upstream, P outlet by P upstream. Now after knowing this ratio, which we after solving we find as 0.5459, we have to place this value in the graph of sonic and subsonic flow regime. So this graph is between the flow rate and the P2 by P1, which is P outlet by P upstream ratio. Now according to that, the position of this ratio, we can find out whether the flow regime is sonic or subsonic. For that we need to find the critical value of the pressure ratio. So to find the critical value, we need the P downstream by P upstream, which is equal to 200 by 800. So downstream pressure is given to us 200 psi and also the upstream pressure is given to us as 800 psi. So this ratio is 0.25. So at the critical point we know the value is 0.5459 and the actual outlet or downstream divided by upstream pressure ratio is equal to 0.25. So 0.5459 will be the critical point, which will be somewhere like this. And the original value from the data we are getting as 0.25, which is left side of this value. So as we move left side, we see this zone is sonic zone. So here the type of flow of the gas well will be sonic. So option A. So in this question, first we needed to find the critical point. For that, using the gas specific heat ratio, we find out the P outlet by P upstream. Now P outlet by P upstream, what we got is gives us the pressure, which is the critical pressure. So above this pressure ratio, the flow will be in subsonic zone, and below this pressure ratio, the flow will be in sonic zone. So when we did the pressure ratio, according to the given data, we see the P down by P up, P downstream divided by P upstream is equal to 0.25, which comes left side of the critical value. Hence, the flow is sonic. Now, next question is, what is the expected daily flow rate MSCF per day of the given data? So, as previously we find out that the flow is sonic flow. So, for sonic flow, the equation for finding out the flow rate, gas flow rate is this. So, by using this equation and taking care of all the units, as the unit should be as shown in these notations, keeping the units like in this notation, and putting those values in the value for the flow rate, we can find out the expected daily flow rate, which will come out as 12743 MSCF per day, which is option B. So here all the values are known to us. K value is known, that is 1.3. Gamma G value is known, which is 0.6. T upstream's value is given, that is 75 degree Fahrenheit, which we have to change to Rankine, as T upstream has to be in degree Rankine. Pressure upstream pressure is also known to us in PSIA. Cross section area of the choke you have to find, as it is given, it's a 1 inch orifice type choke. From that you will find out the area, and C is the choke flow coefficient, which is given as 0.62. Putting these values, you can find out the daily flow rate, expected daily flow rate. So next question is, does heating needed to be applied to assure that the frost does not clog the orifice? So options are either yes or no. So here we have to find out, it is given to us the upstream temperature, which is 75 degree Fahrenheit. So from that we have to find out what will be the downstream temperature. So if the downstream temperature is below atmospheric, and then it below atmospheric or below 0 degree Celsius, or according to the Fahrenheit and Rankine scale, then it can form hydrates and can clog the orifice. So we have to find out whether the temperature of the downstream is low or high. And if it is low, then we will need external heating so that it doesn't choke the orifice. So the equation to find out the temperature at the downstream is given by this equation. So as the flow is of a single, we consider the compressibility factor, that is Z, will be equal in upstream and outlet. Hence we take that ratio as equal to what? K value is known to us. P outlet and P upstream is the value we found out in the first question. From that we will find out the downstream temperature, which came out as 465 degree Rankine, which is 5 degree Fahrenheit. Now ice is formed at 32 degree Fahrenheit. So here heating will be required so that it doesn't choke the orifice. Next question is, what is the expected pressure in PSI at the orifice outlet? Options are A 392, option B 250, option C 437. Outlet by P upstream. Here they are asking what is the pressure at the outlet. So initially in the first question only we did find out the ratio of P outlet by P upstream, which is equal to 2 by K plus 1 to the power K by K minus 1. And the K value is given to us, which is the gas specific heat ratio is 1.3. Putting this K value, we have found out that P outlet divided by P upstream is equal to 0.5459. Now here they are asking us to find out this P outlet. So initially we knew the ratio. Now we have to find out the particular value. So P outlet will be equal to 0.5459 multiplied by the P upstream. So P upstream value we already know, that is 800 psi. So we will multiply 800 with this ratio, and from that we will find out the pressure at the outlet, which is 437 psi. So option C is the answer. So the next question is match the following, where left side they are talking about different flows and at the right side is the definition of the different flows. So the flows they are talking about are bubble flow, slug flow, churn flow and annular flow. And the right side the definitions are given as option A, gas becomes continuous phase, option B, bubbles start to coalesce, option C, large gas bubbles, and option D, continuous dispersed phase and dispersed phases of gas. So we have to match the flow regime with the definition of what occurs in that flow. So as asked in the question, there are four types of flow: bubble flow, slug flow, churn flow and annular flow. So definition of these flows are: bubble flow has a continuous liquid phase with dispersed bubbles of gas. So the first one is a bubble flow, where you can see there is a continuous liquid and inside there are dispersed bubbles of gases. Second is slug flow, which has large gas bubbles. So you can see these are large gas bubbles and the slugs of liquid with small bubbles in between. So it's like in a bubble flow has big gaps of gas bubbles. So that makes a slug flow. Next is the churn flow, where the bubbles start to coalesce. Means the big bubbles, they start to come together and join together, forming bigger gap of gas bubble. And up and down motion of the liquid. Third is annular flow, where the gas becomes the continuous phase and droplets in the gas phase. So annular flow is such that all the large gas bubbles come together and join such that it forms an annular flow, which means inside the whole flow has gases and there is only droplets of liquid inside that gas flow. So from that definitions, we have to now match the following. So bubble flow will come to option D. It has a continuous liquid phase with some bubbles. Slug flow, the second one, has large gas bubbles. So option C. Churn flow, they become to merge. And annular flow is gas becomes the continuous phase. So from that we see option D is the correct answer. So the next question is, for a single gas phase flow through a uniform diameter gas well, mechanical energy equation can be evaluated by considering the negligible effect of kinetic energy and shaft work as follows. Option A, pressure energy equal to gravitational force plus frictional losses. Option B, gravitational force equal to pressure energy plus friction loss. Option C, pressure energy equal to gravitational force minus frictional loss. Or option D, gravitational force equal to friction loss minus pressure energy. So the previous options, they considered that pressure energy is from as the flow takes from higher pressure to lower pressure. That's why the del P value here will be negative. So considering that as negative, we will be able to say that in the mechanical balance equation, the pressure energy can go in the right side. That's why option A comes as pressure energy equal to gravitational force plus frictional loss. So the single gas phase flow, the first law of thermodynamics, conservation of energy, governs gas flow in tubing. Mechanical balance equation is that considering the effect of kinetic energy change is negligible and no shaft work. So for that, the mechanical balance equation says that pressure energy plus gravitational force plus frictional loss is equal to 0. Now in the options here, you see the pressure energy equal to gravitational force and frictional loss. This is said because pressure drop will be negative. So because of that, if you take the negative on the other side, then the first option will be the correct one. Or you can write modify it to that pressure energy plus gravitational energy plus frictional loss is equal to 0. So both of these options are correct. Now next question is that the ratio of Moody frictional factor to the fanning friction factor is. Options are A 1 by 4, option B 4, option C 0.4 and option D 40. So Moody friction factor and fanning friction factor. So Moody friction factor comes from the Moody chart. So the Moody chart can be divided into two regimes of flow, laminar and turbulent. For the laminar flow regime where Reynolds number less than 3000, roughness had no discernible effect and the Moody friction factor, which is also known as Darcy-Weisbach friction factor, can be determined as Fd equal to 64 by Reynolds number. Whereas fanning friction factor is for laminar flow of Newtonian fluids in round tubes, also taken as F equal to 16 by Reynolds number. Now, from these two equations of Moody friction factor and fanning friction factor, you can see they are asking ratio of Moody to fanning friction factor. So, it will be 64 by Re divided by 16 by Re. So, that is 64 divided by 16 equal to 4. So, the ratio will be equal to 4, which is option B. The next question is, now suppose that a vertical well produces 0.71 gas specific gravity gas. The relative roughness of the tubing is about 0.00065. Calculate the friction factor approximated to 4 decimal points. Options are A 0.1772, option B 0.0177, option C 0.1331 and option D 0.0152. So here gamma value is given to us, that is 0.71, and roughness, relative roughness of the tube is given, which is 0.0064. From that we have to find the friction factor. So the equation here we can use is by Goa use Nicaret's friction factor correlation for fully turbulent flow in rough pipes. So as if we go for laminar, then roughness doesn't play any role. But when roughness starts to play any role, we move towards a turbulent flow and use the equations which are used for turbulent flow. So for this case, the turbulent flow equation that we have to use is this one. As the roughness of the tube is given, epsilon by d, which is equal to 0.00065. We will put this value here, and from that we will find out the friction factor, which comes out as 0.01772. That is option number D. So whenever in the question they are talking about the roughness, at that time we have to consider the correlation which is for turbulent flow, and if they are not talking about the roughness, then we can then according to Reynolds number we have to choose. Otherwise, we can initially choose the one in the laminar zone. Now the next question is question number 9, that if the value of d is equal to 1 in equation 1 by q dq by dt equal to minus dq to the power d, then the decline model will be. So options are A exponential, option B harmonic, option C hyperbolic or option D logarithmic. So here according to the value of d, we can find out what is the decline model. So the decline curve analysis is applicable to both oil and gas wells. The production decline analysis is the traditional means of identifying well production problems and predicting well performance and life based in real production data. It uses empirical decline models that have little fundamental justifications. So, this equation gives us uh, it makes us understand what is the curve, decline curve for both gas and oil wells, and this can be either exponential, harmonic, or hyperbolic. Now, B and D are empirical constants to be determined based on production data. When D is equal to 0, it is an exponential decline model. D equal to 1, it is harmonic decline model. And when it is D is between 0 and 1, it is hyperbolic decline model. So from this definition, we can say that when D is equal to 1, it will be harmonic decline model. So option B is the correct answer. The last question is that nodal analysis is performed on the principle of dash continuity. Options are A, temperature, B, mass, C, momentum, and D, pressure. So in nodal analysis, the principle of pressure continuity, only one unique pressure value at a given node, no matter whether the pressure is evaluated from the performance of upstream equipment or downstream equipment. So that is used for nodal analysis. So as nodal analysis is based on the principle of pressure continuity, so the option here, the correct option will be option D, which is pressure. So nodal analysis is performed on the principle of pressure continuity. That will be the answer. हाँ, क्या आवाज? Yes, yes, yes. Not to the both. अगले साल में तो ले गए टेम्परेरी विड्रॉल. हाँ, उसने ले लिया. मगर सर का क्या क्या नाम है? नस्कर. नस्कर सर बोल रहे थे कि हो गया तुम्हारा काम अभी तुम जल्दी से निपटा दो. अच्छी से दिखना चाहिए. अब पेपर का दिखाया? हाँ, उसने एक पेपर दिखाया. उसने छह पब्लिकेशन आउटपुट दिखाया. छह पेपर. हाँ, तो उसने एक पेपर से सबमिट करा है. तो दूसरा दूसरा अंडर बाकी सब अंडर प्रिपरेशन. इसका तो लोकला पर चलता है. एक भी पेपर तो सबमिट. इससे सबमिट किया था. उसने 6 पॉइंट हाई. ठीक है हाई पैट. नहीं, उसका एम ये है कि उसकी स्टार्टिंग में रिजेक्ट हो जाए ताकि उसको और टाइम मिल जाए उसको अच्छे से लिखने का. मैंने भी शुरू किया था टाइम पर. फिर रिजेक्ट होते होते लोग पहुंच. मैंने तो कुछ शुरू भी नहीं किया. मुझे कोई आइडिया ही नहीं है सब कैसे. अरे शुरू करो लिखो लिखो पेपर लिखो. सबसे पहले रिजल्ट डिस्कशन शुरू करो. एक अच्छे से जो फिगर्स होते हैं ना उसके एक पीपीटी में बनाओ. ठीक है. एक फिगर बनाओ. लिंक करो एक फिगर से एक फिगर. फिर उसका उसके फ्लो चार्ट बनाओ. फिर उस फ्लो चार्ट को कंसीडर करो. कंक्लूजन उसके बाद इंट्रोडक्शन. इंट्रोडक्शन अच्छा होना चाहिए. हाँ, बहुत टाइम मुझे लगता है साइटेशन तो इंट्रोडक्शन से ही बहुत लोगों को मिल जाता है. हाँ, इंट्रोडक्शन से ही होता है. मगर पेपर लिखते वक्त पहले इंट्रोडक्शन. इंट्रोडक्शन बाद में प्रिंट किया. फैमिली जो है उसमें मैच अरे तेरे पर रोहन के बारे में. लेकिन वो मेरे स्वभाव. समोसा मिला तो लेकिन गरम नहीं. एक लोग पेपर हो जाते हैं. अभी भी रेट में बैठता हूँ. हाँ यार, बहुत ही बढ़िया उसको. इतना ज़्यादा टाइम लगेगा तो इंसान चीज भी खत्म हो जाएगा, रिव्यू भी बैठ जाएगा नहीं। इतना इतना देर रिव्यू चल रहा है, टेंशन तो होगा यार। हाँ वही तो। एक आध एक थोड़ा रिवीजन देना चाहिए। जर्नल्स में ना वो बहुत सारे पेपर डाल देते हैं एक साथ। अरे इतने लोग भी तो होंगे। हाँ, जर्नल में काफी पेपर डालते रहते हैं, काफी बिजी होता है। फाइल के नीचे दबा होगा मेरे। ये तो गलत है, हमारे करियर का सवाल है। और कभी जो रिव्यू करता है वो सिर्फ प्रॉप होगा, और वो प्रॉप का पता नहीं कब फ्री रहता है, कब बिजी रहता है। मानना पड़ेगा ये, उसमें उसको उसको ज्यादा चाहिए था, उसने वैसे ही किया। उसमें वो खेती का बाद यहीं पर है। मैम का काम करने के लिए, वरना कौन अपने राइट माइंड में 5 साल से भी ज्यादा यहाँ पड़े रहना चाहिए। खुद का भी कोई लाइफ है यार क्या, बस मैम का काम करते हैं। एक ही जगह पे यहाँ तो हम कुछ सीख भी नहीं है। हमें बाहर जाके बहुत कुछ सीखना है, खुद का स्किल डेवलप करना है। यहाँ पे बैठे बैठे बस बकचोदी करता रहता हूँ, कहीं दुनिया में क्या चल रहा है तो आइडिया तो है नहीं। लोगों को परेशान करने को मिल जाना है। बाहर तो नहीं है, बाहर तो लोग इतने परेशान कर रहे हैं। सिर्फ नस्कर सर और जैसा आदित्य बोला नहीं तो कोई भी नहीं था। एक्सटेंशन में करके कोई नहीं आया। के बाद मैम के पास जाके बोलता है, मैम मैंने उस इंटरव्यू के लिए बहुत प्रिपेयर हुआ, बहुत प्रिपेयर किया, कोई सवाल नहीं। कौन था उस इंटरव्यू? वो छोटी क्लास की मैम थी, और आई थिंक कोई और ऑफिसर।
मैम बोलती है किसी का इंटरव्यू बिकॉज ऑफ माय मैं कैसी तो इंटरव्यू नाम के वास्ते हम कब साथ में करते हैं
Hmm.